Okay, so welcome back for another video. Today we're going to be learning about 3.5, which is using the distributive property to help us solve linear equations. So we're learning this in addition to what we've already learned. So always keep in mind and always use those strategies that we've been using in the past. We're just building on the concepts we've previously learned, so kind of a bank of knowledge. So we never want to forget what we've learned, and we always want to use that and keep adding to that bank so we can continue to solve harder and harder problems. But so today, you're going to be using the distributive property to solve equations, like I said. So you may see some problems that you haven't seen in the past, but that's where the distributive property comes in and helps us get through the problems. In addition to the video, I want you to read pages 149 through the top of page 152. So follow along, read those examples, follow along with the examples as well, fill in any blanks where there are. Also, make sure that you are following along with your guided notes with the video, and I recommend at any time, if you feel like you want to go ahead and work ahead on a problem or see if you're doing it correctly, pause the video, try to work it out, and then watch the video and see if you did it correctly, or maybe if you got stuck at a step, you can figure out what the next step should be. Also keep in mind, I'm just showing you one way to solve these problems. There's always multiple ways to solve an equation, and we can discuss that further in class. But today I'm just going to go over a general way to get started on these equations and how to solve them. So let's get started with our first example. We're going to solve each equation for the given variable, and then we're going to check our solution. So we have 5 times the quantity of x plus 2 equals negative 35. So something plus 2, and then I multiply that by 5, must equal negative 35. So again, some of you may already be seeing, what should x be to make this the correct number to multiply by 5 to get negative 35. But again, we're going to be solving the equation algebraically. So order of operations would normally tell us to go into our parentheses and simplify. However, if we go to our parentheses, we can't simplify because it's x plus 2. So what does this problem look like it's set up to do? What does it kind of in general lend itself to doing? Yes, the distributive property. So we're going to distribute the 5 through the parentheses. And again, we're trying to isolate the x, and we can't just jump in there and start to try to take it out because we have these layers that we have to basically peel off before we can actually get to that x. I can't just subtract 2 from both sides because it's not just 2, it's actually 5 times 2. So anyway, let's get started. Distribute the 5 through the parentheses. So 5 times x and 5 times 2. So we end up with 5x plus the 5 times 2 is 10. And that is still equal to negative 35. So these two equations are equivalent, they're just written in a different way. This one's, I guess what you could call the expanded version. So now this is more in the form ax plus b equals c, which is probably something you're more familiar with. So now isolate the variable, get it completely by itself. So get rid of those stragglers, those things that aren't directly attached to the variable. So we are adding 10 to this side. So how do I make that 0? How do I get rid of that 10? Yes, you subtract 10. Don't forget, whatever you do to the left side, you have to do to the right side. Otherwise, your balance is all off. Because right now, as we start, we're saying, hey, both sides are equal. So if I take 10 away, my balance goes like this until I take 10 away from the other side, and now I'm equal again. 10 minus 10 is equal. Is 0. We bring down what remains, so we have 5x equals negative 35 minus 10, negative 45. 5 times x equals negative 45. How do I get rid of the 5? Divide by 5. Divided by 5 on the left side. Have to do the exact same thing on the right side. So 5 divided by 5, it's not 0. If it were 0, now we don't have an x anymore because that would be 0x or 0 times x. 5 divided by 5 is 1, so we have 1x equals negative 45 divided by 5. First off, determine, is it a positive or negative? Yes, it's negative because you have a negative divided by a positive. So we get negative 9. So you can either leave it as 1x equals negative 9, or most likely you'll see it as x equals negative 9. Okay, so now what we have left to do is check the solution. Don't know where my red marker went. Okay, so I'll check it with my blue. So again, we'll copy down the original problem. Okay, so we said x equals -9, so what we can do, because they're equal, we can substitute them in and out and completely substitute or replace x with -9. So 5 times -9 plus 2 equals -35. So now we can use this order of operations, and we can go ahead and simplify our parentheses. -9 plus 2, can we condense that? Yes. Because we know -9 plus 2 is -7. And some of you might be saying, well, why can't I distribute there, because that's essentially what we did over here. You absolutely can. If you distribute the 5 through, you'll still end up at the exact same spot, and I'll show that here in a second. But 5 times -7 is -35. So yes, left side does equal right side. X equals -9 is my solution. That is the only value of x that will make the equation true, so left side equal to the right side. Had you distributed at this point, you'd have -45 plus 10, which is -35. So that's still an option. It's just usually if we're able to simplify in the parentheses first, it just makes the problem go a little bit quicker and fewer steps to maybe possibly mess up one. So that's your first example. Let's look at another one. Okay, so now we have 2/5 equals 0.2 times the quantity of C minus 1. And if you want to rewrite this, so it looks like this. And then start to solve that way you can. Some people like the variable on the left side of the equal sign, but I'm just going to work it directly as it is from here. Again, we look at the left and right side. Can we condense anything? No. Look at my parentheses. Following order of operations, can I simplify the parentheses? No, I have a C and a -1. So what we can do though is kind of expand out this right side. So we have 0.2 times the quantity of C minus 1. So we're going to use the distributed property. So we distribute the 0.2 to both terms, the C and the -1 in the parentheses. So I can just drop down this 2/5, nothing changed there. I'm going to expand this side out. So 0.2 times C, 0.2C. 0.2 times -1, so minus 0.2. So now again, we're in that familiar form of AX plus B equals C. And I can start to isolate the C. Again, this is like peeling away layers. I can't just jump into the middle and get C by itself. I have to start pulling everything away from it so I can get to that variable. So now, here's C. I've got to get rid of this -0.2 first. So how do I do that? How do I cancel it out? I'm subtracting 0.2. So I will be adding 0.2. And if I add 0.2 to the right side, I have to add it to the left side of the equal sign. Again, this is a balance. This equal side keeps everything the same. So if I add 0.2 here, my scale went up a little bit, so I got to even it back out because originally the problem is equal. The two left side and right side are equal. So to even it back out, I add 0.2 and I'm back to equal. So why do I do that? I want this to be 0. 2/5. Well, remember, fractions are just division problems. So if you could either change everything to fractions or decimals, but 2/5 is 0.4. So if I take 0.4 plus 0.2, that gives me 0.6 equals 0.2C. And again, you can punch that into your calculator. Just make sure that if you are plugging in 2/5 to your calculator, you put 2/5 in parentheses. So parentheses 2, fraction or divided by 5, close your parentheses, and then plus your 0.2. Okay, final step. 0.2 times C equals 0.6. Multiplication here, undo multiplication. I need this to equal 1. The only way for that to equal 1 is if I divide by itself. So 1C equals, what's 0.6 divided by 0.2? 3, very good. So 3 equals 1C, or I can rewrite it. C equals 3. Well, let's check to make sure we did it correctly. So we got to plug in our answer. Copy it down, 2/5 equals 0.2 times 3 minus 1. Again, following order of operations, we can go ahead and simplify our parentheses. So 3 minus 1 is 2. 0.2 times 2 is 0.4. Again, how do I check that? Because one's in the form of a fraction, one's in the form of a decimal. You just take your calculator, 2 divided by 5, does it equal 0.4? Oh, good. Yes, it does. So that's one way to check. So good. Got that one right. Check on a couple more of these examples. And again, if you're feeling good with these, go ahead and try the next couple of examples on your own and then play the video and see how you did. Okay, so this one's a little bit more involved. We have 14 minus 2 times the quantity of y plus 6 equals negative 40. So what I want to look is, can I condense the left or the right side? Is there anything I can combine? Well, I definitely can't do anything on the right side, but there's kind of a lot going on over here. Again, the goal is to get y by itself. We want to isolate it. So we got to kind of start, how can I start working my way in to get this y by itself? Well, some of you guys may be saying, this is a positive 14, so I could subtract 14 from both sides and then go from there. And that's 100% correct. That's one way to do it. Some people may be saying, well, hey, I see this 2 out here. Be careful, though, because it is a negative 2. And we can distribute that through. That is also correct. So those are kind of 2 different ways that you could go about this. I think I'll just go ahead and show the distributive property first, and then I will worry about combining my like terms. But again, if you want to subtract 14 first and then work with the distributive property here, go for it. But I'm just going to copy down what I have and use the distributive property. So 14. So here's the key thing, and this is a lot of times where students will make a mistake. We distribute a positive 2 through the parentheses instead of a negative 2. So this negative 2 is negative 2 times y, and negative 2 times a positive 6. So that is negative 12. And that is still just equal to negative 40. Okay, so again, didn't do anything with 14. I have a minus sign in front of my 2, so it's actually a negative 2. So I distribute the negative 2 through the parentheses. So I get negative 2y minus 12. Another common mistake is that we forget to distribute to that second term. So make sure that both terms are multiplied by a negative 2. So now if I look at the right side, or I'm sorry, the left side, I can go ahead and combine some like terms. So I have a 14 and a negative 12. And what does that give me? 14 minus 12 is 2. So I have 2 minus 2y equals negative 40. So now I kind of have that form, that general form of ax plus by equals c. Yes, a couple of things are switched around there, but it's still the same general format. But now, if you notice, I can start to easily get to my y. This is a more familiar problem that we're used to seeing. So I have a positive 2. How do I make that 0? We subtract 2 from both sides. 2 minus 2 is 0. I'm still left with this negative 2y. Negative 40 minus 2 is negative 42. Negative 2 times y, so I've got to get y by itself, so I need a 1y. So how do I do that? Negative 2 times y, I want to undo that, so instead of multiplying by negative 2, I need to divide by negative 2. Negative 2 divided by negative 2 is 1 equals, and negative divided by negative is going to be a positive number. And we get a positive 21. So y equals a positive 21. Well, let's check our work. So copy the problem down. 14 minus 2 times y plus 6 equals negative 40. Again, we said y is equal to 21. So the value of y that makes this equation true is 21. Always keep in mind, each equation that you've written is equivalent to the previous equation. They all are the exact same. You're just rewriting them at different steps. So we have 14 minus 2 times 21 plus 6, and we're saying that's equal to negative 40. So 14 minus 2 times, let's go ahead and simplify the parentheses. So it's 27. 14 minus, or negative 2 times 27 is negative 54. 14 minus 54. Oh, good. Equation's true, left side equals right side. We're good to go. One final problem, and then you'll be done watching the video for today. Again, a little bit more involved. We have the same variable, but we have it showing up in different places on the left side. 12 is just 12. Can't do anything else with it. So let's start to see what we can do on the left side to try to start to get it in an ax plus b equals c format, so we're more familiar with how to work with it. So what does this lend itself to doing? I have 2 times the quantity of 3k plus 1 minus the quantity of 5k minus 3. So my variable, my unknown, is k. So I have 3 times something plus 1 times 2, and then I'm going to subtract 5 times that same something minus 3, and then whatever that comes out to be needs to equal 12. So we definitely want to take some steps and use the distributive property in trying to solve this equation. So first, we'll distribute the 2 through this set of parentheses. So we end up with 6k, 2 times 3k, 2 times 1. Okay, so now, a couple of different ways to think about this, but generally what I say, you're subtracting everything in this parentheses. So you're subtracting a 5k, and you're subtracting a negative 3. Because if you're just subtracting the 5k, we wouldn't put these parentheses here. You're subtracting 5k and you're subtracting a negative 3. So sometimes I suggest, if this were a negative 2, there'd be a 2 there, right? Well, it's the same thing as distributing a negative 1 through. Negative 1 times 5k and negative 1 times negative 3. So again, I'm subtracting a 5k and I'm subtracting a negative 3. So now I look at the left side, and can I combine any like terms? Absolutely. So we have a 6k minus 5k, so that equals 1k. I have a 2 plus a 3, which is a 5. So again, these two are equal. This side is equal to 1k plus 5, and that is still equal to 12. So now, this problem, I only have one more step, but again, it's an ax plus b equals c format. All I have to do is an adding 5, so I subtract 5 from both sides of the equal sign. 5 minus 5 is 0. I have 1k, or if you just want to write it as k, equals 7. Where does that 7 come from? 12 minus 5. So k equals 7. Again, let's do a quick check. I'll just do it down here. Okay, so 2 times, instead of k, I'm going to replace k with 7 plus 1 minus 5 times 7 minus 3 equals 12. So again, order of operations, very crucial here. So let's go to the parentheses. So I have 2 times 21 plus 1. 3 times 7 is 21 plus 1 minus 5 times 7 is 35 minus 3. So 2 times 22, 21 plus 1 minus 35 minus 3 is 32. So that's 44 minus 32. Does that equal 12? Yes, 12 does equal 12. And again, I ran out of room. So that's what we'll be working on, and that's what I expect you to be able to come into class tomorrow. Again, make sure you write down any questions you have or any places that you feel like you were getting stumped or stuck. And I will see you tomorrow. Okay.